All right, hi guys, it's Mrs. Hogan here. So we are going over the last section of Unit 3. All right, so this part, the Unit Section 4, we're going to be talking about proving properties of quadrilaterals. Okay, so we're just proving that triangles are congruent. Okay, so before we do that, let's just review a couple things. Okay, so here in your notes, define congruent. So we know that congruent means that angles or sides that have the same measure, all right? So then angles and sides that are equal, okay? And then we also know that we need to write some congruent statements, all right? So here are some congruent statements. So like these three right here. So this is how we write a congruent statement for sides. So how we know, this shows congruent statements to show that sides are the same, okay? But then this part right here shows congruent statements to show that angles are congruent. Angles are congruent. And we know that because, remember this symbol right here? This symbol means it represents an angle. So just don't forget that, right? So then, okay, congruent triangles, right? So then when we use that to show that triangles are congruent, if two triangles are congruent, all sides are congruent and all angles are corresponding. All right, so this is the part I want to make clear, right? So when you make a similarity statement, so like this guy right here, triangle ABC is congruent to triangle FED, the angles, the letters that are in the same place means that they are corresponding angles. So like this guy right here, A is in the first place and F is in the first place. That means that they are corresponding angles, okay? A and F are corresponding angles. And so are B and E, right, because they're in the second place, and then so are C and D. So when you make your congruent statement, just make sure that you know that the ones that are in the same place means that they are corresponding angles. All right, so just a little review there. All right, so then now we're going to learn about some theorems that prove triangles are congruent. All right, so we're going to use these four. So these four theorems right here. So side, angle, side. All right, so a lot of you are already familiar with this, okay, which is totally great, right? But just to go over it, so side, angle, side, this is something that we can use to prove triangles are congruent. So like this guy, this example right here, so we know that this side and this side is congruent, and then these two sides are congruent, and shows that these two angles are congruent. So then when we look at the order, this shows side, angle, side. Okay, so we show that by side, angle, side. And then our second one is angle, angle, side. All right, so like these two angles right here, okay, they are the same. And then these two 90-degree angles, they are the same. And these two sides, they are the same. So when we look at those orders, okay, angle, angle, side, right? Angle, angle, side. Don't get confused with side, angle, angle. Okay, it's angle, angle, side. Okay, all right. And then the third one, okay, we have angle, side, angle. So this one, these two triangles are interesting because only one side is congruent, and as you see here, the sides that are touching each other, okay, these two sides are the same because they overlap each other. Okay, these two triangles are touching by one side. So that means those two sides are congruent. Okay, and then we know these two angles are congruent and these two angles are congruent. So then looking at that order, I've got angle, side, angle. And then our third one, okay, is side, side, side. If you can show that three corresponding sides are congruent, that means your triangle is congruent, right? So then looking at this guy, so this side is the same. These two sides are the same. And this third last side, they are the same, okay? And then the order we know is side, side, side. That one's easy to remember, okay? But then there are some theorems that we cannot use to show that they are congruent. So for example, so if you have two triangles here, right? Okay, so if I know that these two sides are congruent, and these two sides are congruent, and then this angle is congruent, we have side, side, angle, side, side, angle. Okay, so side, side, angle. So that actually does not prove that triangles are congruent, okay? Because this angle right here, he's not in between the two sides, okay? I can only show it by side, angle, side, but since this angle is not in between the two sides that are congruent, I can't prove it that way, okay? So again, I can't use side, side, angle, okay? And then the last one, okay? The last one, if I know, okay, just delete this guy right here. Right. If I have two triangles here, and I only know that these two angles are the same, and that these two angles are the same, that's all I know. I don't know, and third angle is congruent. I don't know if any sides are congruent. I've got an angle here. An angle does not prove congruence, okay? Does not prove congruence, right? So this looks familiar to you because angle is actually what we use to prove similarity, right? So angle only proves congruence, not similarity. So we're not going to use angle in this example, okay, with this guy. All right. Okay, so I'm going to go over, let's go over some examples in your homework really quick. Okay, so then turn the page over to your independent practice assignment 3.4 continued. We're going to go over a couple together, right? So let's just read the directions carefully. Okay, for each triangle pair drawn, write the parts and pieces you know to be congruent. If there is enough information for proof, write a triangle congruent statement and the theorem that proves the two triangles are congruent. All right. Okay. So then let's look at number 6 here. Okay. So then let's look at the parts I know to be congruent. So I know that these two sides are congruent by looking at those markings, and then these two are congruent, and looks like I have an angle that is congruent. So angle E and L. Okay, so this is actually, if we look at the order, so side, angle, side. Okay, and that is one of the theorems. Okay, looking back right here. So that's the first theorem we talked about. So this actually gives me enough information to tell me that these two triangles are congruent by side, angle, side. So there's my theorem, but then I just need to write my congruent statement. So triangle EFG is congruent to triangle LJH. Okay, and then that's it. Okay, I'm done. And then the 7th one, all right, let's see what we know, what parts we know to be congruent. So I know, looks like these two angles are congruent, and these two angles are congruent. Okay. So I don't know, this doesn't show me that any sides are congruent, and I don't know if any other angle is congruent. So this is actually, shows me, looks like it's angle. But remember, okay, angle, it only proves similarity. Okay, it only proves similarity, not congruence. So I actually cannot use this. So in this problem, I don't have enough information to show that these two triangles are congruent. So this guy, I'm just going to write no. Okay, not congruent. All right. Okay, and that's it. Okay, that's all for number 7. All right. Okay, so then, perfect. So I feel confident that you can do 8, 9, 10, and 11 on your own. Okay, but now let's go back to the notes. All right. Okay, so let's go back to the notes. So on the first page, now we're going to write some proofs. Okay, we're going to write some proofs, and so this is going to be fun. Okay, so when we write proofs, let's look at number 1 here. When we set up a formal proof of these theorems, okay, so like looking at this guy right here, today we'll set up a formal proof of those theorems, and then we'll use them to formally prove properties of quadrilaterals, right? So we're going to use these 4 theorems up here, to write statements, to write proofs to show that these two triangles are congruent. All right, so let's look at number 1 here. Okay. So number 1, first what I need to see, what's really important to know is to see what's given to us first. Okay, so number 1, I'm given that PQ is congruent to QS. All right, so then they have already marked that for me. Okay, so PQ is congruent to QS and TQ is congruent to TR. All right, okay, so when I write my statement, okay, my statement is actually going to be what's given. So my statement is PQ is congruent to QS, and I need to write a reason. The reason why I know they're congruent is simple enough to know that it's given. Okay, I know they're congruent because it's given. All right, and then I just need to double check, include anything else that's given. So another thing we know that is given is that TQ is congruent to QR. Okay, and the reason why I know that's congruent is because it's given. All right, okay, so then that's all that I know. Okay, all I know is that 2 sets of corresponding sides are congruent. Okay, so far I have side. All right, so then we have to do some digging here. Let's see if we can find any angles that are congruent, any sides that are congruent. So I don't know if PT and QR are congruent, so I can't use that. But what I do see here is that 2 angles are congruent. So I know that this angle and that angle, they are congruent. Okay, so that is a statement. Okay, we're going to write that. So PQT is congruent to SQR. Okay, and the reason why I know they're to be congruent is because they are called vertical angles. Okay, so remember talking about that? Okay, if I have 2 lines that intersect each other, okay, the angles that are opposite of each other, like these 2 angles right here, they are congruent. Okay, they are the same. All right. Okay, so I show that one angle is congruent with each triangle. So that means I just show that these 2 triangles are congruent. So triangle PQT is congruent to triangle SQR. Running out of room here. And the reason why I know that is that the theorem that we used was side, angle, side. Okay. Awesome. Okay, so there's number 1. All right, so number 2. Okay, all right, okay, again. So writing a proof, write statements that you know is given. So it's given that JL is perpendicular to MK. And how I know that is because it's given. All right, okay, so let's just look at this really quick. Okay, what does this mean? If I know that JL is perpendicular to MK, so remember, perpendicular means that we have 90-degree angles here. Okay, when you have 2 lines that intersect each other, they create 90-degree angles. So JL intersects MK, which means that these 2 angles right here, they're 90 degrees. Okay, so that's really nice because I already have angles. Okay, angles are congruent. Okay. So then another thing that's given is that KJL is congruent to angle MJL. Okay, all right, so let's just see where that is. So KJL, okay, my drawing was really bad here, which is this angle right here, is congruent to MJL, which is this MJL, excuse me. Okay, I know they're congruent because it is given. All right, so far I have angle. All right, okay, so that's all I'm given. So that means I need to find something else to prove that they're congruent, because again, I can't prove it by angle. Something I do see here is that these 2 triangles, they share a side. Okay, if they share a side, that means they are congruent. So psi JL is congruent to JL, right? And then the reason for that, this is called the reflexive property, right? The reflexive property. Okay, and reflexive property means that when two triangles share a side, hey, I know that they're congruent because they are the same. They overlap each other. Okay, they overlap each other. They share a side. Right. Okay, perfect. Okay, so I just showed that these two triangles are congruent. So triangle MJL is congruent to triangle KJL. All right, by looks like we have angle, side, angle here. All right. Okay, so let's move on to number 3. All right, so new proof. Again, start with what's given. Okay, given that TR, so TR is parallel with US. All right. Okay, so I'm just going to label that here. So TR, it's just this side right here. He is parallel to US. All right. And how I know that is because it's given. Okay. And then I also know that angle U is congruent to angle R. Right, so let's mark that. So angle U is congruent to angle R. Okay, and this is given. All right. Okay, so then let's write this out. Okay. So if I only know that two angles are congruent, or one angle is congruent with each triangle. Okay, so I need to find something else to show that they are congruent. All right. Okay, so as you probably already saw, these two triangles share a side, okay, which means that angle T is congruent to angle TS. Okay, or sorry, psi TS is congruent to psi TS because of the reflexive property. Okay, these two triangles share a side, which means they're congruent. Okay, all right. Okay, so far I have angle side. All right, so then here's another trick. If you know that two sides are parallel, okay, we have some alternate interior angles here. Okay, so remember what that means. If I have two parallel lines and I have a transversal that cuts through them, the angles that are opposite of each other in this transversal, they're opposite of each other and they're inside those parallel lines, they are the same. Okay, so this guy is 50 and this guy is 50. Okay. All right. And it's the same thing with triangles. Okay, so kind of think of this as a triangle here. Okay, we have two triangles. Okay, so then looking at these two triangles here, inside my parallel lines, I have these guys. Okay, so, and then this transversal that cuts through them. All right, the angles that are across from each other. So like this guy is opposite of this guy. They are the same. Okay, because they are alternate interior angles. So then angle UTS is congruent to angle RST. Okay, and then the reason for that is because they're alternate interior angles. And I can only use that if I know that two lines are parallel. Right? If I know that two lines are parallel, I've got parallel lines and a transversal that cuts through it. Right? And I've got some parallel line congruent angles here. Okay. All right. Okay, so now I just proved that these two triangles are congruent. So then I'm going to create another box here because I ran out of room. Okay, so triangle UTS is congruent to triangle RTS. Okay, and the reason for that is because we showed it by angle, side, angle. Wait. Okay. Oh, sorry. Go back here. We showed it by angle, angle, side. Okay, so how we know that these two triangles are congruent is angle, angle, side. Right, and here's our answer right here. Okay, all right. Hey, so then that's how we write a proof. Start with what's given, and then do a little digging. Okay, find out if you can see any angles that are congruent. Okay, vertical angles or alternate interior angles.